Now students, please look at question number 2. Write all the other trigonometric ratios of angle A in terms of sec A. Write all the other trigonometric ratios of angle A in terms of sec A. Students, this question you can try yourself. This is a similar question of question number 1. Similarly, question number 3 and 4 also, see, very easy only. Please try yourself, okay? And if you have any doubts, you can write in comment section. Now, question number 5, which is very important question. Question number 5 of exercise 8.4. Question number 5. In that first question, prove the following identities where the angles involved are acute angles for which the expressions are defined as. We have to prove the following questions. In that first question, it is given cosec theta minus cot theta whole square. We have to prove that cosec theta minus cot theta whole square is 1 minus cos theta by 1 plus cos theta. Please listen here, students. It's a very important question. Cosec theta minus cos theta, cosec theta minus cot theta whole square equal to 1 minus cos theta by 1 plus cos theta. We will start with LHS. Answer. LHS it is given. What is that? Cosec theta minus cot theta whole square equal to cosec theta. Cosec theta we can write it as what? 1 by sin theta minus cot theta. We can write it as cos theta by sin theta whole square. Is it okay, students? Cosec, its inverse is sine, isn't it? So cosec we can write it as 1 by sin theta, and cot we have discussed already in the previous class. Cot is what? Cos by sine. Okay, please note down that this is a very important formula. Tan theta we can write it as sin theta by cos theta. So similarly, cot theta we can write it as cos theta by sin theta. Please note down this. It's a very useful formula. Okay, so this we will be applying wherever tan and cot comes. Okay, so cosec equal to 1 by sin theta and cot equal to cos by sin theta. So here there is a whole square that we put here. Now here comes a very important question, whether we can apply any identities here somewhere or not. We have already studied 3 identities, isn't it? Sin square plus cos square equal to 1 and so on and so. So whether we can apply over here? No. When can we apply those identities? That's the question. Sir, when can we apply those identities then? Please note that we can apply any identity if there is a square in any of these terms. Then only you have to think about identities. Is there any square here? Sin? No. Cos? No square. If it is cos square, then we can start thinking about the identities. Okay. Sin? No. There is no sin in any of these terms. So, till we get square term somewhere, we will just forget about the identities. Okay. So, we need to solve till we get square terms somewhere. Okay. So, now looking into this, we will try to solve this. So, here both the denominators are same. So, we can write sin theta one time. Numerator it will be 1 minus cos theta whole square, isn't it? Now separating the square for the numerator and denominator. I give the square separately to both the numerator and denominator in the next step. Okay, students. Now look at here. Here we got a square term, sin square term, sin square theta. So you have to start thinking about your identities. You have 3 identities basically, from which you have again learned some other identities, whether we can apply that over here or not. What is sin square theta? Sin square theta, it is 1 minus cos square theta, isn't it, students? So that we will substitute over here. Okay, so that is 1 minus cos theta whole square. In the numerator we are not making any changes in the numerator. Keep it as it is. Sin square theta. What is sin square theta? Apply the identity. That is 1 minus cos square theta, isn't it? So that we will apply here. That is 1 minus cos square theta. Okay, that is equal to what? Here we have 1 minus cos theta whole square by 1 minus cos square theta, isn't it? I just rewrite the step there, okay? The same step only. So here, when we are looking into the denominator again, we can understand 1 minus cos square. 1 means what? That is 1 square, isn't it? So that is 1 square minus cos square. It is of the form a square minus b square. Okay, students, we have the identity, algebraic identity we have, that is what? A square minus b square is what? A plus b into a minus b, isn't it? Okay, now this is of the form, the denominator is of this form, a square minus b square. So this we can reduce to a plus b into a minus b form, isn't it? So 1 means what? 1 square, okay? So 1 square minus cos square is what? 1 plus cos theta into 1 minus cos theta. Hope it is clear. So that is what? 1 minus cos theta whole square. In the numerator we are not making any changes right now. Now we can cancel this 1 minus cos theta. In the numerator 2 times 1 minus cos theta is there, isn't it? So this square and this 1 minus cos theta will get cancelled. So what's remaining? What's remaining now? That is equal to 1 minus cos theta by, the square is gone, 1 plus cos theta. That is equal to the RHS. Finally, hence it is proved. Okay, students, so that is 1 minus cos theta by 1 plus cos theta. Hope it is clear. Please take the notebook neatly, students. Thank you.